Hello students, welcome to classroom. I hope you are all doing well. So today we will be continuing with our chapter 10, and the topic that we will be discussing today will be power of accommodation. So let us continue with the topic. Now, power of accommodation. This is a very simple topic. The first thing that we will discuss is what is accommodation. So if I ask you what is accommodation, class, what will be your answer? So accommodation means to receive. Okay, the literal meaning of the word accommodation means to receive. Okay, so power accommodation means the power of the eye lens, okay, to receive, light rays. So this is what the topic will be about. So first of all, we will try to define what actually is power of accommodation with respect to the human eye. So let us write on the definition. So definition, take down the definition. So reminding that to grab a pen, a notebook and a pencil, and to take down the notes, because notes is going to be very much helpful for you all. So what is power accommodation? Let me erase this one now. So the definition, the textbook definition, the ability of the eye lens to adjust its focal length, the ability of the eye lens to adjust its focal length, the ability of the eye lens to adjust its focal length to help us see far as well as nearby objects is known, KNOW, is known as power of accommodation. Power of accommodation. So this is the definition of power of accommodation. The definition of power accommodation reads: the ability of the eye lens to adjust its focal length, okay, so as to help us see. So we can write here, so as to help us see, okay, to help us see far as well as nearby objects is known as power of accommodation. In simple words, our eye lens helps us to see nearby object as well as far distant object. So this ability of the eye lens to help me see near object as well as far distant object is known as power of accommodation. So this is not very far. Of course, this is near, but this may not be very far. But then outside the room, I can see far. Okay, I can even see the horizon. I can see the mountains and valleys. So my same eye lens helps me see this marker pen, okay, which is just at my arm's distance. And at the same time, if I look outside the window, outside my room, outside the house, I can see the horizon, I can see the mountains, the trees and all that. So this is known as power of accommodation. This eye lens has the power to help me see near as well as far distant object. Okay, so this is all possible because my eye lens has the power to change its focus. Okay, if you remember, if you have watched the previous video, there I have explained very well, okay, that our eye lens, the biological eye lens that God has given us, has a very special ability, which is that it can change its focal length. Okay, it can change its focal length. So by changing its focal length, it helps us see nearby object, okay, and if we want to see far distant object, okay, then the focal length changes. So the focal length can decrease and the focal length can also increase. So this flexibility, okay, is what our eyes carry. within all of us. Okay, so this is a very unique ability which we carry, which we have in our biological islands. Okay, so the power of the ability of the eyelens to adjust its focal length so as to help us see far as well as nearby objects is known as power of accommodation. So our eyes, okay, our eyes receives light coming from far distant objects, okay, as well as our eyes receives light coming from near objects also. So our eyes receive both rays coming from far object as well as light coming from near object. So this power, okay, this ability of the eyelens to receive light, okay, this is known as power of accommodation. Okay, I hope it is clear enough. Okay, we will discuss more into it. Okay, so now let us understand in detail, okay, with diagram, like what happens or how our eye lens behave when when light comes from far object, and how our eye lens behave when light comes from near object. So let us draw two diagrams, one for far and the other one for near. Okay, so let us draw two diagrams here. So let us draw an eyeball here. Let us draw this. Let's say this is the eyeball. Okay, then our lens is here. So this is our lens. Okay, then let me draw another one here also. Then lens, this is the lens. Okay, then this is the retina. It's not glass, this is the retina, and the retina will be here. Okay, now for the first one, it will be distant object. Okay, so distant object. So when we are looking at distant object, so this one will be for distant object. Distant object. And the second figure will be for near object, when you are looking at near object. Now time to draw the light rays. Okay, now how do I draw? It's very important, how do I draw? Okay, so these things, okay, when you start learning, these things are very crucial for you, but with practice this will get very easy. Okay, so how do I draw? Okay, suppose say I'm learning for the first time, the same problem I will have it with me. How do I draw? Okay, I have drawn the eyeball, okay, and I know some parts of the eyeball. This is the retina, this is the lens, okay, and all that. Now how do I draw the rays? So see here, we are drawing for distant object, means object kept far away from us. Okay, we are talking about far away objects. Okay, most likely infinity, the object is at infinity. So remember this class that light rays coming from infinity, they always travel parallel. Okay, so the light rays that we should be drawing here should be parallel. Okay, we will draw only two rays. So draw two rays, but draw those two rays traveling parallel with respect to each other. Okay, so draw two rays. So let's draw ray number 1, okay, and let's draw ray number 2, these two. So these are two rays, okay, and where is the object? The object is at infinity. Okay, the object is at infinity. So two rays from the object kept very far away from the eyelens. Okay, these two rays, they are heading towards the eyeball. It has already entered the eyelens. Okay, and now what will happen to them? Now our eyelens, which is convex in nature, will converge the light rays. Okay, will converge the light rays exactly at the retina. Okay, which acts as the focus. Okay, which acts as the focus. Remember, okay, in convex lens, whenever light rays which travel parallel with respect to each other enter the convex lens, where do they meet? They meet always at focus. So this retina is also our focus. Okay, and the distance from focus to the eyelens also is considered as the image distance. Okay, remember that. So convergence will take place. So let us converge it, and then on convergence they will meet at this point. This is the retina, is not? This is the retina. So image is formed at the retina. This is the retina. Okay, and this is how your eyes helps you see, okay, far away objects. Okay, there is an object at far distance from your eyelens, and then your eyes, it converges those light rays and helps you see the far distant object distinctly and clearly. Okay, now we move to the second, which is near object. If the object is nearby, okay, so now the object will be close by. So let us draw the object close by. Let's say the object is here, okay, a small object. Okay, now since the object is nearby, now the biggest question here is, how do we draw the light rays? Should we draw the light rays like this, which we drew earlier here for distant object? No, we don't draw. Okay, for this the light rays will be drawn like this. It will be drawn like this. Okay, remember this class, it will be drawn like this. Okay, it will be drawn like this. So light rays, they are emerging from this object, which is kept not very far from the eyeball. Okay, so these are light rays, okay, coming out from the object. Now they have found their way to the eye lens. So what will happen? Refraction will take place, bending will take place, and then where will they bend together? They will bend at the retina. So our eye lens, which is converging in nature, will converge these, okay, will converge these light rays, and then where will they meet? They will meet at the focus. Even for this also, this is the focus, this is at the retina. So the image of this object which is nearby, okay, is also formed by the retina. Likewise, the image of an object which is far away from the your eyes, the image is also formed at the retina. Okay, so this is called power of accommodation. Okay, power of accommodation is simply the ability of the eye lens, okay, to adjust its focal length so that, okay, so that it helps us see far object as well as near object. This flexibility of the eye lens to accommodate, to receive light coming from far object as well as near object, this is known as power of accommodation. I hope it is clear. Okay, now according to your textbook, two more very important information are given to you. They are the least distance of distinct vision and the far distance of distinct vision are given to us. Okay, so the least distance of distinct vision means the minimum distance at which, okay, at which if you view the object, okay, the image will be formed distinctly in the retina. So as per the textbook, the least distance of distinct vision at which the object should be clear so that the writings on the object will be clearly visible to me is 25 centimeter. All right, so we can write down here the least distance of distinct vision, just important information. So least distance of distinct vision, DISTINCD. I am very weak in spellings, so please don't mind class. Distinct vision is equal to 25 centimeters. So this is the least distance of distinct vision, means, okay, an object kept closer, lesser than this, okay, than this length, which is less than 25 centimeter. Say you are keeping an object at 10 centimeter. 10 centimeter is very close to my eye. Okay, so I have problem seeing the inscription on this marker. Okay, it's written Luxor, but then I have difficulty seeing that. Okay, it strains my eye. So to view these initials clearly, I have to keep it, okay, at the minimum distance of 25. More than 25 is okay, but okay, at least at 25, okay, I don't have there is less stress in my eye, so I can view it comfortably. All right, then, so this is called the least distance of distinct vision, means the minimum distance at which your eye can comfortably read, okay, can comfortably read, or your eye can comfortably form the image of what you are seeing. It's called the least distance of distinct vision. Okay, now we go to the far point. Okay, according to the scientists, according to opticians who have studied the human eye, for them, they say that the least distance of far vision, okay, the least distance of far vision for a normal healthy eye is infinity. So it is infinity. So if you have a good eye, okay, if you have a good eye, then there is no far point for you. The far point for you is infinity. Okay, but okay, even if you have a healthy eye, okay, this will apply to all of us. This applies to all of us. Okay, whether you have a bad eye or good eye, this applies to all of us. So for a normal healthy eye, this will be the least distance of distinct vision. For a normal healthy eye, okay, for a normal healthy eye, the far point is infinity. So for a normal healthy eye, so the far point, let's write far point, okay, far point according to the scientist is infinity. Okay, so the scientists have not bothered to set a criteria here. They have just said it's infinity, so that means it's infinity. Okay, and I don't know what is the length of infinity, so just remember these two very important points. Okay, now some important things to discuss here. Now this is a short topic, okay, the actual topic is over, but then there are some extra discussion that we can go. Now if I ask you this question, okay, let this be case 1 and let this be case 2. So if I write here, will it be visible or not? I wonder. Okay, so let me just erase this one and say case 1. Okay, and then I hope it's visible. Case 2. All right, I pray that it's visible. Now in case 1 is for object at in case 1 the object is at far, and at case 2 the object is at near. Okay, near position with respect to the eye lens. So the question here is, okay, in which case, case 2 or case 1? Okay, in which case does the eye lens, okay, undergo a lot of stress? Okay, in which case is the eye lens under more stress, or in which case is the eye lens working a lot? Is it case 2 or case 1? What will be your answer? Okay, look carefully and think on the answer. Pause the video and think on the answer. Which will be the answer according to you? Will it be case 1? Are the eye lens in case 1 under lot of stress, or are the eye lens in case 2 under lot of stress? Okay, pause the video and think the answer and resume the answer. All right, so by now maybe you have the answer with you. So the answer is case 2. Yes, so it's in case 2. The eye lens, okay, the crystalline eye lens are under a lot of stress and duress in case 2. Why so? See, it is so because, see here, in case 2 the object is nearby, okay, and then look at the rays coming from the object. They are diverging rays. So they are diverging rays. Okay, had it been, if there were no eyeball, the rays will go like this. The nature of the rays will go like this. The rays are about to go like this. Okay, the rays will go like this. Okay, but see, since there is this eye lens, okay, now instead of going like this, okay, they will converge. It's not this eye lens. Since we have convex eye lens, the convex eye lens will converge the light rays. So it's very hard, okay, it's very much difficult for the eye lens also to convert these diverging rays, which is not so in this case. In this case, the rays are traveling parallel, and then it is much easier and very much comfortable for the eye lens to converge these rays. So the eye lens finds it easier and comfortable to converge parallel light rays, whereas the eye lens has to undergo a lot of stress, okay, to converge divergent rays. So under this case, the eye lens is under more stress and more duress, okay, because here the eye lens has to converge divergent rays. Okay, so a lot of work, a lot of stress, okay, a lot of power, okay, a lot of power. Yes, the question can be, okay, in which case the power is more? Then the answer is again case 2. Power is more here, okay, more power is here, okay, more power is here, okay, more power is here. All right, more power is here. Okay, remember the formula, P is equal to 1 by F. Okay, so short focal length, the object is here, okay, so the focus is so short here, so power is more. Short focus, more power. Here the object is far, the object is infinity, so focal length is also, since the object is far, the focal length is also more here. If more focal length, power is less, because we know this relationship, P is equal to reciprocal of focal length. Greater the focal length, less the power. Shorter the focal length, more the power. So more power in case 2, okay, more power in case 2, correct, and less power in case 1. Okay, more stress to your eye, less stress to your eye. So whenever you're looking at far distant scenery, whenever you're looking at far object, okay, it's quite relaxing and then it doesn't stress your eye much. But if you're looking at nearby objects, when you're reading a book, a magazine or a manga, what happens? Okay, well, if your interest is too much, then you may not feel this, but okay, but this is true, okay, in practically it is so true that if you are made to look at an object, a signboard, okay, continuously for minutes and minutes, it's gonna cause a stress to your eye. Okay, you will have to blink and then you'll be blinking a lot. Okay, so why? Because your eye is under a lot of stress. Your eye muscles, okay, are under a lot of stress. Okay, the object is nearby, the signboard is nearby, and then the letters that are written are nearby, and you are told to focus on that letter, okay, for a longer period of time. So in this condition, your eye lens, okay, are converging the light rays because the object is nearby. So they are converging and they are forming the image on the retina. So the eye lens, okay, are using more power. So your eye lens are under a lot of stress, so which causes which causes stress to your eye lens. So this in the long run, okay, is bad for you. Okay, this is bad for you. So we feel more stress, okay, when we look at nearby object. Okay, when we look at nearby object, our eye undergoes a lot of stress. Okay, that's why the doctors advise, okay, not advise us not to browse on the mobile phone for too long. Okay, because the same thing is happening. Okay, we hold the mobile phone too close to our eyes, okay, and then see, it's nearby, so your eye lens are converging the video or the image, whatever you're seeing, so it's causing a lot of stress to your eye, so which is not good in the long run. Okay, so in my childhood days, we watch a lot of TV. So during those time, our parents told us not to watch TV at close proximity. But most of our friends and most of the people at that time, they did not listen, and children used to go and watch the video very close to the TV screen. Okay, so we did not know why our parents warned us not to watch like that. But nowadays we understood that the reason is very scientific. Maybe our parents knew, or maybe they did not know, but they were warning us, and then for us too, we did not know, we disobeyed them, and then we watched, and today some of us were wearing glasses. Okay, so one of the reasons why why our eyesight became bad is because of such habits. So let this serve as a soft warning to you all also, my dear students who are watching a lot of videos close by, that when you watch anything close by, okay, this is happening. You are putting a lot of stress to your eye lens, so which is not good. Okay, so anything overdone is not good, so do not overstress your eye lens. Okay, so remember, under this case, your eye lens is under more stress, so this is gonna cause irritation. This is gonna cause stress to your eye lens. All right, so this is the topic. Okay, now so today's topic is a small topic. It's about power accommodation. Definition is given to you, and we have to explain what happens to our eye, okay, when we see far object and near object. All right, now before I end this video, I have a question for you all, so I want you all to answer me the question. So I hope you all wrote these points. Okay, so reminding you again and again, students, that you can always pause this video, okay, go back and then write whatever point you have missed. That is the advantage of learning from YouTube, okay, or from recorded videos. So please do that. So the question that I have for you is this. So question: a person is seeing an object closer to his eyes, full stop. What changes in his eyes will take place? What changes in his eyes will take place. The options are A. Pupil size will expand. Pupil size will expand. Option B. Ciliary muscles will contract. Ciliary muscles will contract. Let me use a new marker. Focal length of eyelens will increase. Focal length of eyelens will increase. And option D is light entering in the eye will be more. Light entering in the eyes will be more. I hope the options are visible. So the question is, a person is seeing an object closer to his eyes. What changes in his eyes will take place? The options are A. Pupil size will expand. Option B. Ciliary muscles will contract. Option C. Focal length of the eyelens will increase. And option D. Light entering in the eyes will be more. So either one of them is the correct answer. Option A or B or C or D is one of the correct answer. So please try this question and you comment the answer. You comment the correct answer in the comment box. Okay, so I'll be going through the answers and I will check the answer. So please participate and comment the answer in the comment box. Okay, comment box, sorry. So class, this is it for today. I'll end the video from here and I'll see you again in the upcoming next video. Thank you all for tuning in and God bless you all.